So good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms and homes around the world. And we really appreciate you guys joining us from home. We really appreciate you guys joining us from home or your classroom, especially amidst a really weird start to the school year as we continue to highlight amazing people and places around the globe. So October is classically our space month. We've got 30 plus broadcasts featuring engineers, astronauts, scientists, explorers from all around the globe. But today I'm particularly excited as we are bringing back one of our all-star speakers, Dr. Stofan. So she is the former chief scientist at NASA. She's the current John and Adrienne Mars director of the Smithsonian National Air and Space Museum. And today she's going to talk about the most elite scientific research lab in the world, one of the most amazing crowning achievements of mankind in the International Space Station. So if you joined in before, it's our backdrop for today. We're really excited to dive in with her presentation. She's got such a unique perspective on this amazing place. And so thanks so much for joining us, Dr. Stofan, and looking very forward to this.
Oh, it's going to be really fun. So what I'm really hoping is that I'm going to get a ton of questions. So I'm going to give everybody a little introduction about what is the space station, why is the space station, what have those astronauts been doing up there for the last 20 years? And so it's really amazing. But if you're 20 years old or younger, you have not lived a day of your life when there haven't been 3 to 6 people living in space a few hundred miles above us. That is incredible. There are people who actually live in space. And I want you to really feel the wonder of that. But as I go through this introduction, I really want you to think about questions that you have, because that's what we're going to have a lot of time for. So I'm going to go ahead and share my screen. Let's see if it works.
This is always the fun part. We'll find it.
It's the fun part. Yep. Where is it?
So share screen. On the bottom of your page, it is in StreamYard, and then we bring it up and we'll walk you through it from there. I'll let you know.
Okay. It says screen sharing, share.
Yep. And then entire screen, and you can go from there and click a few buttons and.
I got it.
Perfect.
I think I figured it out.
You know, we can put astronauts in space. Can we figure out screen share together? We'll find out today.
All right. We're going to try this one more time.
Take your time. By the way, for everyone who's joining in live too, if you guys are asking questions and you miss anything in the broadcast, these all go straight to YouTube and live there forever. So you can always watch after the fact as well. And again, all our space programs straight live to YouTube and Facebook throughout the month. So when you click the share screen on the bottom, it brings you up a big box in the middle of your screen.
Yeah, the problem is it's telling me that we're not having permission to share my screen.
Oh, well, then we'll have to just talk about the space station without some pictures today, or I can bring up pictures as you talk about specific things. If there's anything you'd like me to show or anything you'd like to share. I don't have your slide deck, but I can always share pictures from my end.
Okay. The only thing it says it'll work if I quit and come back.
Of course it says that. So it's your call. You can either leave and come back in a minute, or you can just chat with us. And if there's any specific pictures that you would like to share or any pictures, I can bring them up on.
I'll come right back. If you give them a quick introduction, I'll come.
Lovely. Well, we'll wait for Dr. Stofan to come back. Miss Shirt's class, welcome into you guys as well. And again, all our broadcasts, YouTube and Facebook, you can always check them out there live after the fact. A lot of our sessions fill up really, really quickly, so you can always tune in and tune into any YouTube channel on any one of our programs. We're going to be taking questions from YouTube throughout the day. So if you're on YouTube, let us know and we'll make sure to answer your questions. All right, take 2 of screen share. Fingers crossed. Doing it. See, it did take you leaving and coming back.
Yep, and it did it fast even.
It did. We're killing it.
All right. So again, we're going to be talking about the International Space Station. And one of the favorite things of mine, and you can go to this anytime you're bored, is there's an amazing website that actually gives you this view. It's a live stream. So all you have to do is Google live from the International Space Station. And this is what the astronauts get to see as they go above our beautiful, beautiful blue planet. And you can really see, and this is one of my favorite things about the International Space Station, is this view it gives us of our atmosphere. And look at that tiny, tiny, thin atmosphere above the Earth. And you know, when we're here on the surface of the Earth and we look up, our atmosphere seems huge. But when you're in the space station, you get this sideways perspective of the Earth where you see that our atmosphere is this precious thin layer that supports all life on Earth. And that's why when we think about things like climate change, this view is, I think, a really important one to keep in mind. Our atmosphere is this thin, precious layer that protects us from space, and we need to think of our planet as spaceship Earth. So when we talk about the International Space Station, I want you to think of it almost like how we treat our own planet. It's a little world where you have to sustain life. Now, I wanted to start with just a little bit about me so that when we come back, you might say, how did you ever get interested in this stuff? That's my family. When I was little, up in the upper left, my dad cut our hair, so you can see how my sister and I had to suffer. But my dad was actually a rocket engineer, and the launch that you see in the top center there is an early launch back in the early 1960s. It was the first launch I ever went to. So my dad was actually a NASA rocket scientist. We went down to Florida for the launch, and as you can see, it did not go very well because early in the days of NASA, they were really developing how to fly rockets. So you make a lot of mistakes, you fail, and you figure out from those failures how to eventually succeed. So I ended up studying volcanoes. I studied volcanoes on Mars. That's the largest volcano in the solar system, Olympus Mons in the upper right. And in the lower right is a volcano on Venus called Mat Mons. And you can see that's me. In the lower left, I'm in Hawaii, out doing some work on a volcano, and I'm standing next to something called a skylight. So the lava flow I'm standing on is actually a baby lava flow. You can see it's steaming. It's only about 2 days old. So the tread on my boots would melt because the rock is actually still hot. And every once in a while, there'll be a hole and there's still hot lava flowing underneath this crust. And you can look down into that hole. And the reason I'm all squinched up is because there's so much heat coming out of that hole or skylight into the lava flow. It's like if you go to your oven on Thanksgiving and you open it up and this blast of hot air hits you in the face. That's what it's like standing on an active lava flow. So I got interested in NASA and exploring and in the planets. Now, this is the International Space Station. It's obviously really an amazing laboratory. It's actually the size of a football field, and you can see it's mostly taken up by those long black panels, which are the solar panels that provide energy to the space station. It's about the size of a 6-bedroom house, so it's pretty roomy inside, and it's made up of modules that you can see here, and the modules come from the United States, from Russia, from Japan, and from the European Space Agency, which along with the Canadian space agencies are the partners on the International Space Station. So each of these laboratories, and we'll hopefully get a little tour of the laboratories later, each of these laboratories provide different areas for the astronauts to live, to eat, and to do different experiments on the International Space Station. I wanted to get back to the why. Why are we doing this? Why are we exploring? So what you just saw in this little movie, first of all, was Mars, the red planet. But what happened? You saw that it flipped around. This was going back in time. So 3.5 billion years ago, Mars looked like this. It was a blue planet, just like the Earth. It was covered in water. But Mars is very tiny, so in time, it lost a lot of its atmosphere. It got very cold. It was a little too far from the sun. So Mars went from being this, very Earth-like planet to the red planet that we know it is today. So the big question scientists have is, did life ever start on Mars? Did it evolve on Mars the way it did here on Earth? Because the conditions on early Mars were so similar to the conditions on early Earth. Now, the problem is we want to go to Mars and find that out because obviously this is what Mars looks like today. It's kind of like a desert. It's beautiful. In fact, I could show you pictures of the Earth that actually there's places in Utah, places in the Middle East that don't look too different from what Mars looks like today. This is a place on Mars called Gale Crater that the Curiosity rover is exploring. And you see all those layers of rock here on the surface. And what our rovers are doing is they're going along and they measure what are these layers of rock. And those layers of rock tell a story about Mars's past. They tell us about that blue Mars. And obviously what we're trying to do is really understand, could life have evolved on Mars? But because the time period was very short that Mars was Earth-like, what we're really looking for are fossils. And I think it's going to take geologists like me and maybe aspiring scientists like some of you out in the audience to go to Mars, actually break open some of those rocks and try to find evidence that maybe there was once life on Mars, or even still could be life on Mars. But the problem is, it's about 8 months to get to Mars. Mars is super far away. So 8 months to get to Mars, then you've got to get down to the surface and do work, and then you've got to come home. And so we're talking about a 3-year mission. So how do we get ready for a 3-year space mission? How do we know that we actually have the technology that we really need to get ready to go to Mars? That's what we do every day on the International Space Station. We're getting ready to learn how to live in space for long periods of time so that we can get to Mars and do the really cool exploration that we want. These are just some of the international astronauts that have worked on the International Space Station, and you can see they're doing all kinds of different things. Up in the upper right is Peggy Whitson, who is actually an American woman astronaut who spent more time in space than any other astronaut. She lived on the International Space Station for about 10 months last time she was up. And we've done a really special study. Up in the upper left there, you see two guys who kind of look alike. They're actually twins. That's Mark and Scott Kelly. Scott Kelly, who's the astronaut on the right, he spent a year up on the International Space Station. And twins are really interesting because their bodies are copies of each other. While Scott was up in space, we actually was studying his blood, his genes, his bones, his eyesight. And we had Mark on the ground, who was a retired astronaut also, as kind of a control point. Could we understand by using twins the effects of space on the human body? Because it turns out when you go up into space and there's no gravity, your bones actually change, your immune system changes, everything changes. And so we need to understand those changes so that we can prepare astronauts to get ready to go to Mars. And on the bottom left, you see two other astronauts who are working on things. You see lettuce on the right side floating around. That's lettuce that we're growing in space. So we're also doing things like Samantha on the left is looking at experiments to try to have technologies that we can use on a long space mission. And Kel there on the right is thinking about how we grow food on the International Space Station to, again, get ready for these really long times spent in space. This is a little tour that's been put together of all the different experiments you see. There's the plant growth chamber. That's what I was talking about, growing food. There's a 3D printer. We can talk about more of that in the question period. You can't take every tool you need with you, so how about printing them in space? We actually have a rodent laboratory where we're doing all kinds of experiments on rodents, because that helps us understand things like bone loss, all kinds of technologies that you need. And frankly, the most important was, can we keep enough water? Humans need a lot of water to live. Can we keep enough water on board? We can talk more about that, because we actually recycle urine on the International Space Station for the astronauts, so that we don't have to bring as much water along with us. But also the very air that they breathe. We have to keep it clean. We have to keep it healthy. So just keeping the astronauts alive. And then there's the toilet, and we can get into that next at the end. So again, the thing the astronauts say that they love more than anything else is looking out the window. And this is an area of the space station called the cupola, where the astronauts can actually look out the window and do Earth observations. We take scientific instruments up to the space station. We've had one that's been looking at cloud formation. We take astrophysics that look out into the universe and study dark matter and dark energy. So the space station isn't only about trying to get astronauts ready to go to Mars, it's also a really great scientific platform that we can use. But you can see out the window there a giant hurricane, so we can look down at the Earth and study what's happening in our own atmosphere and on our surface. And what all of the astronauts say that most affects them when they're up in space is something that they've come to call the overview effect. When you're up in space, you can't see countries' borders. All you can see is that this is our spaceship Earth, and we all live on one planet together. One of the things I wanted to end with, and then again, please get your questions ready, is to talk about who gets to go. You know, in the beginning, most of you have probably seen photographs of the early space program, Mercury, Gemini, Apollo. And you know, all the astronauts looked the same. They were all white men. And one of the things, as we know through history, is we've had all kinds of different people participating all along, whether it's Bessie Coleman, who was the first Black woman to get a pilot's license back in the 1920s in the upper, the center of this top of this slide. People like the Tuskegee Airmen down in the lower left, Mae Jemison, who's in the upper right, who was the first Black woman to fly in space, Ellen Ochoa, who's in the center bottom, who's the first Latina astronaut in space, Katherine Johnson in the lower right, who did all the math that helped us to get to space. We need everybody to help. If we're going to get humans to Mars, if we're going to figure out how to solve big problems, we need to make sure that everyone is welcome and that everybody can participate. And part of the way we do this at the National Air and Space Museum is to make sure that we're telling everybody's stories, that everyone belongs, everyone can contribute. And in fact, they have been all along, and it's helped us to get to where we are today. So that was our whirlwind tour, and I think we still have plenty of time left for questions.
We have tons of time left for questions, and thank you so much for a beautiful presentation. I'd recommend, especially for our older kids today, Katherine Johnson in the bottom right of that photo. Hidden Figures is a movie and book that covered the story of her, some other amazing women back in the early days of NASA. So do check that out if you get a chance. It's an incredible read and watch. So before we dive in with our live questions, I want to kick us off with one that I'm not sure we're going to get, but I think is really important for our students to sort of think about. NASA is doing some really ambitious stuff nowadays. We are thinking about Mars. We're planning for a lot of deep space robotic missions. But one thing that I want to harp on particularly is the Gateway Moon potential space station. So how are we going to take the lessons that we've learned from the ISS and apply it to a potential moon station that could open up the moon to all sorts of amazing
I
discoveries?
didn't talk about, because I was really focusing on that. How do we get to Mars problem? But part of how we get to Mars is by going via the moon. You know, that whole thing about that trip to Mars being 7 to 8 months long, that's a really long time, right? If something goes wrong after month 1, you're in trouble because you can't turn around and come back home. It doesn't work like that. Planetary trajectories, how we get from one place to another. And those of you who don't like math, math is really important, because math is how we figure out how to get humans from the Earth to Mars, Earth to the moon. So the problem is you can't turn around. So let's go somewhere and practice all those technologies I was talking about. How do we have a working toilet? How do we make sure the astronauts have clean air to breathe? Let's practice at the moon, which is 3 days away. Something goes wrong, you can come back home pretty earlier. Let's go there and practice. Let's build the transfer vehicle that's going to take humans to Mars. Let's test it at the moon, and that's called Gateway. And it also allows for private companies who want to get down to the surface of the moon, maybe to look at, are there things there worth mining? Are there minerals on the moon that we can use, which we know there are from our long-time studies of the moon? Let's use that also as a platform to get down to the surface. It's all about practicing to say, all right, we've learned how to live in Earth orbit. Let's go to the next step and live out by the moon and feel comfortable. And then in about 15 years, we'll be ready to take that big step to Mars. So you guys are actually the Mars generation, because you're the generation that will be the first people to walk on Mars.
I love that message, and it's something that we really harp on in all our space presentations, so I'm glad you added that in. Thank you, Ella. All right, I want to go to Ms. Langer's class in Coburg, Ontario. If you guys have a question for us to kick us off from our live classes, come on in and take us away.
Okay, can you hear me?
Yep, you're all good.
Good. So Bella in my virtual classroom here in Coburg, Ontario, wants to know, Dr. Stofan, if you have ever been to space, and if not, would it be a dream of yours, and where would you go?
Yeah.
You know, you saw that first rocket that I ever watched launch, and you notice it didn't go very far. It blew up on the launch pad, and I think that had an effect on me. So I never really wanted to be an astronaut. The only thing I've ever wanted to do, though, was go to Mars. And I think if I had had the opportunity to go to Mars, I would have sort of overcome my concern about rockets, which again, I saw a lot of early rockets not do so well. So it never made me want to be an astronaut. But all my astronauts who are friends, they're always telling me, Ellen, you have to try this. You have to come up someday because the views of the Earth are so beautiful. But if you could offer me a ticket to Mars, I'd be there right away.
It's really interesting, actually. The vast majority of people we've had on this broadcast would not personally go to space. So I'm glad to hear someone who's drunk the Kool-Aid and is really excited to get up there. Awesome. All right, I'm going to go to our grade 12 class in Kitchener-Waterloo in just a minute, but Ms. Yaffine's class in Toronto has passed along a bunch of questions in the chat bar, so thank you to you guys. So I'm going to take two sort of back-to-back here. What's the average out time that it's okay to stay in space for, and is there an age limit to go up to the space station?
You know, there's no age limit for the space station, and the oldest astronaut that's gone up was actually John Glenn. Now, some of you might say, well, I've heard of John Glenn. Well, why have I heard of him? John Glenn was actually the first American to orbit the Earth. And he was also the oldest person. So much later, he was actually a United States senator, and he actually flew on the space shuttle as kind of a guest when he was about, I think he was about 78 years old. So he's the oldest person. There's actually no age limit. There's no reason if you're healthy, you can absolutely go up in space. And I forget, what was the first part of the question? It was age limit and...
Yeah, and is there an average time that it's okay to be in space? You talked about a 1-year mission and potentially longer.
What we know is the effects of microgravity, the negative effects on the human body, your bones start to decalcify, your immune system starts to lose function. Those happen almost right away. And so in that sense, the negative effects of microgravity happen right away. The longest people have stayed in space has been a little over a year. There were a few then Soviet Union astronauts who stayed up on Mir, which was their early space station, for longer than a year. And they came back, and what happens, and then we've had Scott Kelly, who spent just about a year, and then Peggy Whitson, who spent about 10 months. What we know is it takes a couple months back on Earth for the negative effects of microgravity to go away. You actually get taller in space because your spine expands, but once you come back down to the Earth, the gravity squishes you back down again. That happens almost right away. So there's negative effects. They reverse once you come back, but we don't really know how long people can stay in space without gravity. We don't have enough data, and that's one of the things we hope to gather more information on in the next 5 years. We're going to send more people up to the space station to stay for a year. We're going to try to extend those time periods out in space. Ultimately, you do want a spacecraft that creates gravity, and you can do that by spinning a spacecraft. But that's a little bit hard. It's a technology challenge that we still need to work on. So in a lot of science fiction movies, you'll see that there seems to be gravity, but in general, they always have a spinning spacecraft because that creates gravity.
Yeah, I was going to highlight to our students, The Martian is a great example of where they try to compensate for that. The Expanse series of books and or TV show, both. Yeah, I'm on book 8. It's fantastic. We can talk about that later. But yeah, so there's some fantastic sci-fi out there to help, sort of highlight those insights in a really visual and fantastic way. Great question, guys. All right, let's go to Ms. Allenot's class. Again, Kitchener and Waterloo, welcome in, guys. If you have a question for us, go for it.
With your background in planetary geology, what is your view on the extraction of resources from the moon, and what are some possible consequences?
I think when we look at the extraction of resources, I think you really have to say, is there a cost benefit? And so we can utilize resources here on the Earth, and then we can recycle them. For example, there's a lot of rare metals that are in, for example, cell phones that are in finite supply on the Earth. And so you have to say, well, what does it cost us to regather that material, recycle it in order to use it again? And then you think, okay, but if those metals also exist on an asteroid or on the moon, what is the cost to go to that place, to extract them, and to bring them back to the Earth? Right now, it's still cheaper to use what we have here on the Earth or recycle what we have here on the Earth. But you can imagine a situation 30, 40, 50, or for those of us who love the expanse, hundreds of years from now, where we need just so many of those rare earth elements. There's not enough here on the Earth to sustain what we need. And then you're going to have to go out, and there will be a benefit. So what I'm really watching for is, when is that tipping point? When is the tipping point where you say, I can say that the cost of going and extracting it is actually worth it. We're not there right now. We're just at the early stages of saying, how would you even go to the moon, extract resources? So we're in the study phase, which is appropriate, but I do get a little worried. Sometimes you see a lot of hype about this in the press, like, we're about to go mine on the moon. No, we're not. We're going to go learn how to mine on the moon, because someday it's probably going to be necessary. But right now, frankly, it's still a lot cheaper to do it here on the Earth.
Fantastic. One of the coolest groups of missions in the last few years have been landing on comets, landing rovers on things that are trillions of miles away, which is really, really exciting science. And again, NASA has some of the most robust education programs in the world. Dr. Stofan, you showed a few amazing clips of that. So students, in fact, I'll bring it up in a banner. If you go to NASA's education website, there's a lot of really cool resources there, more videos to keep the learning going. So I'd encourage you to do that so you can follow up on all these questions after the broadcast is done. I want to go to Ms. Short's class now, joining us in Sarnia. So if you guys want to come into the session, go for it.
Okay, go for it, Taya. Right there.
Are you guys always on the lookout for places to live other than Earth?
Ooh, good question.
We are, and it's usually from a scientific reasoning, not like, oh my gosh, we have to abandon the Earth. Because what we're really trying to understand is, why is the Earth the only planet we've found that's truly habitable? So when we're looking at planets around other stars, which is really going crazy right now, because we've had things, we have a mission up right now called the Transiting Exoplanet Survey Satellite. We had a mission called Kepler, and those missions have found tens, if not 100 planets around other stars, which are in an orbit where they could potentially have water on the surface and thus be able to sustain life. So we're looking for potentially habitable planets, especially around other stars. So far, we haven't found any. That's mostly because of technology limitations, I think, not that they don't exist. In a few years, we're going to launch a telescope that Canada has participated in called the James Webb Space Telescope, that's going to start looking at the atmospheres of planets around other stars to say, can we actually say there's water in that atmosphere and maybe it is really a habitable planet? But this always brings me back to the point. Carl Sagan, who was a famous astronomer, he said, we've looked, and so far this pale blue dot of Earth is the only place we found that we can live on. And he said, this is where we make our stand. And to me, that really is a clarion call to say, this is the planet we have to take care of. We have to solve climate change. We have to make sure that this planet is habitable for generations going forward, because there is no planet B. We have not discovered it. And if we discover it around another star, it's going to be so far away that it is not suitable for us to think that we're going to be able to get there to continue humanity on. This is where we make our stand.
Pale Blue Dot is probably the most beautiful speech ever made. So I encourage, if you guys check it out on YouTube, you can read the section of the book. It's an amazing thing to follow up this broadcast with. Another quick note on the James Webb Space Telescope. We've had Natalie Hulett numerous times in both official languages in Canada on this broadcast, highlighting all the stuff about the James Webb, so if you want to follow up. And secondly, because it's just to follow up on this question, this idea of living on another planet. We have lots of reasons for wanting to go to the moon and live there, wanting to go to Mars and live there. But the reason is not that the Earth is going to die and we'll need to live at those other places. No matter what the situation is, the Earth will always be the most natural home for mankind. There's nothing we could do to Mars that would make it more habitable than the Earth. And if there was, we could just do that same technology here on the Earth to make it better, right? So it's not like we're running away. There are other cool reasons, but I'm really glad we got that question. Thank you, Dr. Stofan. All right, I'm going to go back to Ms. Langer. Actually, Dr. Stofan, you're really busy. Do you have time for 4 more questions, one from each class?
Yep.
Perfect. Okay. Ms. Langer's group, if you want to come back in, go for it.
Okay, my class is wondering, you were talking about the gateway to the moon and practicing on the moon. Have you started any of those types of missions or practices?
Yeah.
So NASA right now has a program called Artemis, which is a plan of this administration to try to get humans back to the moon by 2024. We'll see if that happens. We're still waiting. It relies on a rocket that NASA's been developing called the Space Launch System. So the first launch of the Space Launch System is going to be next year in 2021. And then they'll eventually start crewed missions where they'll first send a crew around the moon and bring them home. And then the plan is after that is to actually land humans back on the surface of the moon and to put this gateway, these initial modules, sort of just how we built the space station. And we've been working with all the partners, including Canada, for in the original partnership of the space station to move outward. They're in a lot of talks with them. How are we going to do this? We definitely want to do it as an international community. And so it's on its way, but so far we haven't had a mission back to the moon from NASA yet. The Chinese have obviously recently landed on the moon, and the Chinese space program also has a very active lunar program.
Yeah, it's really the most exciting time to be in space possibly ever. I mean, 50 years ago, we sort of set out, we had the Apollo program, we did all these amazing missions that you've referenced throughout your broadcast today. But really, for students today, not only do the generation that's going to land on Mars and do all these amazing things, but just in terms of the breadth and scale and ambition that's being shown by space agencies and private companies around the world, it is a really exciting time to be fascinated with this field. So I'm really glad we get to talk on all this today. All right, let's go back to Miss Alanott's class. If you guys have another one, go for it.
Having worked on a long-range plan to get humans on Mars, do you think common space travel to Mars will be a part of the foreseeable future? And how close are we to colonizing Mars?
Ooh.
No, I actually don't think it's going to be common. What I do think is going to become common in the next sort of 15 years is no, I want to say normal people, non-astronaut, non-trained astronauts going up to potentially low Earth orbit, or at least doing flights with companies like Virgin Galactic, companies like Blue Origin, where you see companies coming forward. It's still only for the very wealthy. The tickets are very expensive. But the idea is, when we first had airplane flight, when you first had helicopters, it was only for the very wealthy, right? Because it was expensive, because the technology was new, the technology development was new. But if those companies are successful, or you see follow-on companies being successful, I think you're going to be able to see everyday people understanding what it's like to be able to get that beautiful view of the Earth. Mars is just hard, and the surface of Mars is extremely hostile. Once you leave the Earth's protective magnetic field, you're in deep space where you're subjected to both solar radiation and incoming galactic cosmic rays. That radiation increases your cancer risk. It can actually do neurological damage. And the surface of Mars does not have a magnetic field. So you're even subjected to some of that radiation on the surface of Mars. Space is hard. Mars is hard. The technology to get there is hard. I think we're actually a fairly long way away. And when I say fairly long way, I mean sort of 50, 75 years before normal people could potentially get to Mars. It's going to be a while yet. It's hard.
Yeah, fantastic. Thank you so much. All right, let's take two more questions from groups that their webcams are out, so we're going to just share them from the chat bar. But Miss Yaffine really wants to know about resources to space. Do you guys take normal water to space when you go there? How do you get protein in space in the ISS? How are we feeding and watering these people?
And that's that's a great question, because some of that research we're doing on the Earth, on the ISS right now the ISS is what we call Earth dependent. Just last week, there was a launch here on the coast of Virginia that was sending supplies up to the space station. We send food up, either through Japan, Russia, or the United States. If we don't send food up, the astronauts would not be able to eat. We do send water up, though right now we're recycling about 85% of the water on the International Space Station. And that means we catch the water for when they do a sponge bath, and it means we recycle pee. We recycle urine so that they can have water to drink. the goal is for a Mars mission, we want to recycle sort of 95% of the water. And that's going to be one of those systems that we're testing out at the moon as we go to Gateway, is can we go from being Earth reliant on the International Space Station to Earth dependent on out at the moon, to Earth independent when we go to Mars. Now, obviously, we would send supplies. We would pre-stage supplies on the surface of Mars. So you're not going to really be truly Earth independent. This is also, you saw that 3D printer, and I was hoping we'd have time to come back around to that. They've actually, the idea of 3D printing food, 3D printing clothes, where they wear their clothes up on the International Space Station until they're yucky and smelly, and then they actually throw them away. So what if instead you could put it through like a grinder and then 3D print some clothes? We need to become reuse, recycle. So aren't those things we need right here on Earth? So the technologies that we're developing to become Earth independent, how do we grow food in space with low water? How do we reuse everything we have so that we're not using up new resources or needing them from Earth? These are the same solutions that we need right here on Earth to combat climate change.
Outstanding. I'd recommend as a nice follow-up to this too, sort of the conservation perspective that you've touched upon. Netflix has a recent documentary, A Life on Our Planet, with David Attenborough, hero of mine too. So he talks about the space exploration leading to an environmental movement on Earth, and I love that we can sort of tie that back together on the other side. So just really encourage you guys to check that out. Dr. Stofan, we have only one more question. So if you wanted to talk about 3D printing for a minute, by all means, we'd love to hear your insights.
Sure. One of the first things they actually 3D printed on the space station was a specialized tool. So again, when you think of this idea of how do you become Earth independent, you really have to think of how do I make things in space? How do I create things? Because if I have to launch every little last bit of things I need with me, I'm not going to have enough room in my spaceship. And in the space world, launch mass is the really important variable, because the more weight, the more stuff you launch into space, the bigger the rocket is. The bigger the rocket is, the more expensive it is, because you need more lift capacity. So we're always trying to reduce how much we take with us, which means how do we then 3D print in space, whether it's food, whether it's clothing, whether it's tools. Now take that to the next extreme, on the surface of the moon, on the surface of Mars. How do I build a habitat out of what I find there? And so there's actually lots of experiments going on around the world of people taking sort of analogs to lunar and Martian soil, which is basically kind of ground up lava rock, which we have a lot of here on the Earth, and saying, how do I take that material and form bricks that I could then build a habitat with? And there's been all kinds of fun NASA competitions, European Space Agency competitions, where they ask students around the world, how would you design a Mars habitat using Martian materials? So this idea of taking 3D printing from a tool on the space station to a habitat on Mars is where we need to get to eventually.
Yeah, very, very cool. Great question, guys. All right, we'll wrap up with one more. So Ms. Short's class wants to know, they get up to the ISS, they're there for 10 months or a year, and then they come back. How do we get these astronauts safely back to the Earth's surface?
The astronauts right now have been going to the space station and coming back in a Soyuz rocket. So it's a Russian rocket, and that's because the United States used to launch astronauts on the space shuttle. The space shuttle was 1970s technology. We lost 2 space shuttles on Challenger and Columbia, and they were really no longer, it was just outdated technology. It was no longer safe. And so for the last number of years, the United States has been reliant on Russian rockets. And so it's launched Canadian astronauts, European astronauts, Japanese astronauts have all gone via Russia. So when they come back in a capsule that lands on the ground in Kazakhstan. It's a bit of a bang when they land. And that's how we've done it, except for about 3 months ago now, the United States had the private company SpaceX launch the first astronauts from Florida up to the International Space Station. And when they came back, they actually landed in water, which is obviously how the Apollo program always landed. They come down in the water and a ship comes and retrieves them. And that first test from SpaceX went really well. The Boeing Corporation next year will launch astronauts also. So we're going from having it be solely government to having private companies involved, because the technology is not sort of experimental anymore. It's standard, and private companies can take over where governments used to have to be involved. So that's really fun. We've been really excited about that. And keep an eye out. The next mission up to the space station by SpaceX is, I think right now it's scheduled for no earlier than the end of October, sort of October 30th, 31st. Keep an eye out. I'm really excited for that mission. We have a friend of the Air and Space Museum, an astronaut named Vic Glover, who's on that mission. So we're really excited about it.
Fantastic. You are so passionate about this, and it shines through in everything you've been talking about. We absolutely love having you here at Exploring by the Seat of Your Pants. And we'll leave you to your day in a minute, but is there one last message you want to share with us just to wrap up, to talk about the ISS or your own passion for space?
You know, one of the most important things I think is right there in the name, International Space Station. This is no one country who's done this. Canada has been key. All the nations of Europe have been key. The United States, Russia, Japan. It's now, I think we have over 20 some countries have sent experiments up to the space station. We have students from around the world sending experiments up to the International Space Station. Space is a place where even when we always don't get along on here on Earth, it's literally higher ground where we can go and do things as an international community, as humankind. And the Apollo astronauts, when they came back from the moon in 1969, you know, one of the things they said was people kept saying to them, we did this, whether those people lived in Indonesia or Ghana or in Toronto. It was, we did this. Humanity did this. Humanity is exploring. And to me, the exciting thing about the International Space Station, it's turned that into reality. We can't do this alone. We need to do it together as an international community, because the smart people live all around the world and we need to work together.
And I can't think of a more beautiful message to wrap us up than that. Dr. Stofan, thank you so much for your time today. And as you know, what we do at the end of every broadcast is I'm going to bring in our other classrooms. So Ms. Allenot's class, Ms. Langer, Ms. Jaffine, if you want to join me in saying a big thank you and goodbye to Dr. Stofan today. You're all in. Thank you so much, guys, for joining us. We hope to see you all soon and have a wonderful